Today, I'm going to prove two triangles similar in a proof. All right, and I know some of you guys get squeamish. We start whining a little bit. Oh, back to proofs, but these are not bad. Okay, these are not bad today at all. All right, proving two triangles similar in a proof. A review of yesterday. I gave you guys three methods of proving triangles similar. I gave you the angle-angle method. I gave you the side-angle-side similarity method. And I gave you guys the side-side-side similarity method. But good news. Only one of these methods is going to work when we do a proof. Only one method is going to work out of those three when we do a proof. And it's going to be angle-angle. That's the only one I could possibly use in a statements reason proofs. And here's why. You guys remember what side-angle-side and side-side-side meant about the sides? They have to be in the same ratio. And to do that, I need numbers. I need actual lengths of sides to compare. And I never give that to you. We have never done a proof this year where I have actually wrote the lengths of the sides on there. So sides, angle, side, and side, side, side cannot be used in a similar triangle proof. It's only going to be angle, angle. So that is your one job. Find two pairs of congruent angles, prove the triangle similar. I ease you into it on this first proof. I'm telling you that WR and VB are parallel. Prove the two triangles similar. The only way I can prove triangles similar in a proof is by using the angle-angle method. So first person off today. First person, find a pair of angles that are congruent for me. Start us off here. Find a pair of angles, please. At the top, Vinny, find a pair of angles that are congruent.
WSR and VSB.
Why?
Because they're vertical angles.
All right, there we go. There's our first pair. Vertical angles are congruent. Pair number one, down, done. All right, let's keep moving. There's got to be another pair up there equal to each other, right? And that's why I gave you the given that those lines were parallel. Give me another pair of angles that you know must be congruent. We got this. 13. Sophia, another pair?
Angle SWR and VBS, because parallel lines imply opposite or alternate interior angles.
Did you mean RWS, not the vertical angle, I think you said?
RWS?
You said W and B, right? You meant W and B?
I meant to say SWR.
Okay, yep.
Sorry.
So angle W congruent to angle B. Yep. And then remember the reason here? Parallel lines imply alternate interior angles congruent. Good. Now, you could have also done this proof without mentioning the vertical angles. You could have just mentioned both pair of alternate interior. That was another way of doing this proof without mentioning the verticals. And guys, we're good. This is it right here. Triangle WSR. Just make sure you put the similar symbol and not congruent to BSV. Method, angle, angle. Not too bad. Just have to find two pairs of angles. Not too bad at all. All right, we got the triangle similar. Now there's a part B question. Now I will give you the lengths. You got SB as 10, WS 15, SV 20. How about RS now? Well, if they're similar, let's continue on now. And this is not part of the proof. It's just a second part. If the triangles are similar, we learned yesterday, their corresponding sides are proportional. If triangles are similar, corresponding sides are proportional. So we got to match up the correct sides now. So what's 15 going to match up with? What's 10 going to match up with? How can you tell what it's going to match up with? Use the statement you just wrote. Use the similarity statement. That'll show you what sides match up. All right, so give me two sides that should match up right now. Two sides that should match up. Here we go. Anthony, you got two side lengths that should match up?
15 and 10.
Good. 15 matches up with 10. And again, this is how I write my proportion. If you guys rather write 15 over X, and then in the other side, write what they match up with, I don't care. That's fine. So 15 matches up with 10. That means X must match up with 20. Again, how did Anthony know 15 and 10 matched up? He looked at the darn similarity statement. WS matches up with SB. Cross multiply and we're good. 10x equals 300 here. X equals 30.
Should you normally show this work for the cross multiplication when you're solving this?
What do you mean, instead of just going to x equals 30? Or,
Well, is the stuff that you're showing in blue, is it something we should write down in the proof?
no, it can. You can do it in the. There's no statement or reason I'm looking for. You can do it inside the column, sure, but it's not like I'm not going to put a reason here like cross multiplication. It's just an algebra, a secondary algebra question. That's it. So where you do it is up to you. Anything else on this one before we go to something that's a little slightly tougher? Not too bad though. Okay, next one. I'm not doing many proofs here today, as you can see. This is the last proof I'm going to do because there's only so many you can do where you find just pairs of angles. Oh, we got a rectangle on our hands. Perfect. We got to remember a property about a rectangle that may help us out here. I got two perpendicular lines, AQ and BD. And then please now look for the two triangles I'm asking you to prove similar because I think they overlap here. BAD, similar to BEA. Okay, they do overlap. And I'm asking you guys to prove it similar. Only method you have is angle in a proof. Only method you have is angle. All right, so start looking at the givens. It's a rectangle, and I have two perpendicular lines as well. Anybody want to add anything to your diagram or tell me anything about this diagram? Anything. I'll take anything about this diagram based on the givens. 6, here we go. Caroline, anything you want to tell me about this diagram?
Since AQ is perpendicular to BD, that means there are two right angles.
Yep, there are two. I'm only concerned with one, the one that's actually in one of my triangles right here. So I can put a right angle symbol at angle AEB, and I can put it in my proof that it's a right angle. Perpendicular lines form right angles. All right, so I have a right angle in my yellow triangle, which must mean there's got to be a right angle somewhere in my blue one, right? Because if I'm going to go angle, I need two right angles to be congruent. Anybody know where another right angle would be in my diagram here? Where's another right angle? Use a given. Use a given. 12, here we go. Lucas, do you know where another right angle would be?
Angle DAB.
There you go. Why? What type of figure is this, Lucas?
It's a rectangle.
Perfect. And you guys remember. Oh, go ahead. I'll let you finish, Lucas. Go ahead.
And rectangles form right angles.
Yep. In a rectangle, you have four right angles. So in step 3, I can't put this in step 2 that it's a right angle because it's a different reason. But in step 3, I can put angle DAB is a right angle. Just what Lucas said there. Rectangle implies all right angles. So I'm using a little quadrilateral property there. So everyone see why I have two right angles in that diagram. Now I need to tell you they're equal so I can get the first A in angle. AEB congruent to DAB. Right angles are congruent. There you go. There's the first A in angle. The right angles being equal. Whew, now we got to search. I think we've used all our givens as much as possible. We got to search now. Where is that other angle? Where are the other pair of angles going to be in those two triangles? Look, dig deep. I'm not going to call on anybody here, so if anybody wants to just let me know where that other pair of angles is, go right ahead. Where is the other pair?
Reflected angle at B.
There is a reflexive angle here. Yes, an angle shared by both triangles. There is an angle shared by both, and that angle is angle ABD or ABE. You can call it either way. ABD, congruent to ABD. Good job. Everyone see it? This angle right here, reflexive. And there you go. There's your second angle, and we're good to go. So a little bit trickier than the first one. The angles weren't as easy to spot, but they're there. We knew how to find them. So triangle BAD, similar to triangle BEA. Angle, angle. Questions on this one right here? Angle, angle. All right, so that's, we're not done yet, but that's the proofs for tonight. Find two pairs of angles and you're good to go. We will make these proofs a little longer tomorrow. You know, I'm going to ask you what happens after we have the triangles similar. What do we know now? And we'll talk about that tomorrow. But we definitely need more practice setting up proportions and solving them. So that's what we're going to do for the last couple 10, 14 minutes here. Before we solve some algebraically, I want to introduce you to a new theorem. All right, this is where the honors portion of this course comes in. All right, I don't think they show this in the geometry classes, so this is where the honors portion comes in, that I want to show you this new theorem called the side splitter theorem. Side splitter. Here's what it says. If you have a line that is parallel to one side of a triangle. So take a look at my first diagram I have here. I have BD, which I'm giving you is parallel to AE. So you have a line that is parallel to one side of the triangle. If you have that, then it divides the other two sides proportionally, meaning if you have a line that's parallel to one side of a triangle, it divides the other two sides. So watch. CA, line CA is being divided proportionally. CA over BA will be in the same ratio as the other side, CE. So that divides it up into CD over DE. Okay, so you have a line that's parallel to a side of the triangle, divides the other two sides proportionally. CB over BA equals CD over DE. That's called the side splitter theorem. Side splitter. But the lines have to be parallel. We can't just assume it divides it proportionally. We got to know the lines are parallel. All right, so let's go to number one so you can see this one in action. I got the parallel lines, right? So using side splitter, it says, all right, I have a line that's parallel to another side of the triangle. It splits the other two proportionally. So I can say here 4 over 6 equals y over 9 using side splitter. Makes it a nice, easy proportion, doesn't it, guys? 4 over 6 equals y over 9. 6y equals 36. Y equals 6. All right, but I do also want to mention this. Side splitter is not required. It's not required. All right, it's just an easier way to do the problem. Watch. You guys could have done this problem last night on homework. So let me show you the alternate way of doing this. Versus, I'm just going to call this yesterday. You don't need side splitter to solve this. You could have done this on your homework last night. Here's why. Two, three. Here we go. Luke, give me a side in the small triangle that you know.
4.
4. All right, stay with me, Luke. 4, Luke, corresponds to what full side in the large triangle?
9.
Oh, what?
Oh, both sides?
Okay. 4, right? You have 4 from this small triangle. What does it correspond with in the big triangle with? A length of what? Here you go. Here you go. I got 4 and I got y. There's my small triangle. I got my big triangle here. 4 corresponds with this side right here. How long is that side? 10. So I could put 4 over 10, everyone, right? Is the same as, what's another side from the small triangle? Y over what's y correspond with in the big triangle? Y plus 9. So I could do it this way as well and still get, watch, 4 over 10, y over y plus 9, 10y equals 4y plus 36. Look at this. Look at this. 6y equals 36. Y equals 6. So I could still do this problem without the side splitter. I am showing you this if you would like to use it or not. It's like a bonus. Sometimes the algebra goes a little quicker using side splitter. But it can be done both ways, using the side splitter theorem or just matching up the sides. Still works. Questions on both methods there, because you guys are going to have to figure out what you're comfortable with. Okay. Let's go on to some serious big boy, big girl algebra now on number 2. All right, what do I have here? AE is a length of x. AD is a length of 1. DB is a length of x. EC is a length of x plus 2. I tell you DE is parallel to BC. Got it. All right. We have our choice here. We could use, this is an example where side splitter could be used. Or I could just match up corresponding sides and write my own proportion. Your call. All right. I showed you side splitter, so I feel like I should use it again. All right, I did show you and introduce it to you, so I'm going to use side splitter to do this. So everyone sees AC and side AB are getting divided proportionally. X over X plus 2. So there's AC getting divided proportionally. Over AB getting divided proportionally into 1 and X. If you don't want to do that, match up the sides. That's fine. All right, cross multiply. Uh-oh, now panic sets in. You see x squared, you know what time it is. Equal to x plus 2. You know what time it is. You see an x squared, it's factor time. Maybe. I might have to use quadratic formula here, but maybe. Factoring. One side equal to 0. Keep the x squared positive. Always keep the x squared positive. So everyone go ahead, move over the x and the 2. Move over your x and 2. You get x squared minus x minus 2 equal to 0.
Wait a minute. Oh, that's a 1. I thought that was a 7. Oh.
Yeah, that's my 1, yeah. All right. In an honors level class, if I can factor something, I am going to factor it. If you guys feel like you're weak, nervous, not confident in your factoring ability, use quadratic formula. It can be used every time. I just hope you use it correctly. But I am going to factor in an honors class anytime I can factor it, which I can here. So here you go, guys. 2 numbers that multiply to -2 but add to -1. And this is why I'm factoring. It's not that bad. 2 and 1 are my numbers. How do I make them add to -1? Make the 2 negative and the 1 positive. All right, set them equal to 0, and let's see what our answers end up being. X minus 2 equals 0. X plus 1 equals 0. X equals 2. X equals -1. This isn't Friday where we just accept all our answers regardless of what they came out to be. Anybody see an issue with one of my answers? I hope you do. There's an issue with one of the answers.
One of them is negative, and that can't happen since one of them is just x, and you can't have a negative side length.
Perfect description right there. Perfect explanation. AE is x, so is DB. Can't be -1, can't have a negative side length. So this is a time where, yep, we are going to reject the answer of -1 and only accept x equals 2. And you guys saw it said find DB in the directions. We labeled DB as x, so we're done. DB is 2. Questions there? So, yep, factoring. If you didn't believe me, hopefully you do now. It is used throughout the entire unit. All right, one more. I'm just going to set it up and you're going to go on your own with you. DE is parallel to BC. I have, let's see, AD is 6. DB is x minus 1. And ED is x. CB is 6. Find ED, which is x. So I'm solving for x again. All right, before you set up your proportion, I want you guys to notice, yes, the lines are parallel, but side splitter, no use here. There's no use for side splitter here. Do we see that? Because if I give you the lengths of the parallel sides, that's not side splitter. It would be if I gave you AE and EC. If I put that x and 6 on AE and EC, then I could use side splitter. So you cannot use that here. You cannot use it here, guys. So you are forced to match up the corresponding sides to write your proportion. But again, side splitter, no use here. I need the other two, I need the sides, not the parallel sides, the other two sides. I need those values, which I don't have. All right, so help me set it up. Here we go. Let's start it off. Ryan, can you give me a side in the small triangle?
X.
X. This is an easy one, Ryan. What's the X match up with in triangle ABC, the bigger one?
6.
6. Good job. So there's my first two. X ED matches up with 6 CB. Here's the tougher part. The other side of the smaller triangle is 6. Anybody want to chime in and tell me what side AD matches up with in the bigger triangle? Side AD matches up with what? AD matches up with
X plus 5.
well, AB. Yep. Well, we're going a little ahead of me there. AB. Everyone see that? AD and AB match up. So what's the length of AB? Well, it's 6 plus X minus 1. Combine those like terms. Yes, you get X plus 5. That is side AB when I combine my like terms of 6 and -1. All right, you guys are on your own. Go ahead. You got this. Cross multiply. See your two answers at the end. One's not going to make a lot of sense. You got this. You can factor it. You can factor it. If you don't prefer to factor it, use quadratic formula. Just make sure you get whole numbers out at the end here. If you need work on quadratic formula, stop by, set up a time with me. I'm hoping you guys are getting out 4 and -9 eventually when you factor or use quadratic formula. 4 or -9, but if you plug -9 back in, it will give you a negative side length. So the only thing I could accept there would be x equals 4. Two numbers that multiply to -36, but add to 5. All right? Questions there at all? All right. A couple proofs using angle tonight, and more algebra. If you want to use side splitter, use it. If you're not comfortable using it, don't use it then. All right? Okay, you guys have a good day. I will see you tomorrow.